So we're still working in polynomials. This irrational zeros is super short because I could probably just tell you to do it. We probably wouldn't have to go over it, but we're going to anyway. This says to find all the zeros, write answers in simplest form. And we're talking about irrational zeros. So first of all, let's talk about what makes a number an irrational number. Can anybody tell me what they think that is? Or you could explain to me what a rational one is. Like, I'll take either one. Because they're kind of, the definition's kind of, okay. So maybe you can tell me, like, is 1/2 a rational number? What is the root word of rational? Close. Well, yeah, okay, yes. And another form of that, like ratio, rate, and they're all kind of made of ratios, right? All a fraction is a ratio, one thing over another, right? So to be a rational number, you have to be able to be made into a fraction of whole number over whole number. So 0.5 is a decimal, but it is a rational number because I can represent it as 1/2. Make sense? Pi is an irrational number because I cannot represent it as a fraction. 22/7 is an approximation, but it's a bad approximation, so that doesn't work. If you take a decimal that goes on forever but does not repeat, I can't make that into a fraction, so like the square root of 2, the square root of 5. All right, so your irrational numbers that we're going to be working with right now are like square roots, pi, numbers like that, okay? Anything else, if it's a decimal, that's okay. It could still be rational as long as I could make it into a fraction and it be the same. Make sense? All right, so what we're really talking about here is our square roots. So it says find all the zeros, write answers in simplest form. So we're going to factor just like we've been factoring. It's just that the ones that you've been factoring, most of them, they have come out to be, you can factor them all the way. So let's look at this one. My A is not 1, so I don't get to start with my 2 parentheses. So I'm going to have to multiply 4 times 8. That gives me 32. I need 2 numbers that multiply to give me 32, positive 32, and combine to give me a negative 33. What is that? Negative 32 and negative 1, or the other way around, doesn't matter. So I get 4x squared minus, no, it's 4x to the 4th, and I was even going to remind you, when these are to the 4th, make sure you use the right exponents down here, unlike what I just did. Minus 32x squared minus x squared plus 8. All right, so then I'm going to group these and group these. Notice I did not put parentheses here. Some of y'all put parentheses at this step, and I think that leads to some confusion sometimes. So I'm going to factor out my 4x squared. That leaves me with x squared minus 8. Then I can factor out a negative 1, and that also leaves me with x squared minus 8. So now I have 4x squared minus 1 times x squared minus 8. Step, can I factor some more? Yes, because this is a difference of squares, so this gives me 2x plus 1 times 2x minus 1, then that is not the difference of squares, so I'm going to leave that as x squared minus 8, right? Okay, so as of right now, that's as far as I can factor. So then I'm supposed to find my zeros, so mark this off like this. So I know that this is 2x plus 1 equals 0, 2x minus 1 equals 0. From now on, I'm going to skip the equal 0 step because you should know that, but I just want to make sure we're all on the same page here. X squared minus 8 equals 0. So that means here I get x equals negative 1/2. Here I get x equals 1/2. And then when I start to solve this one, I get x squared equals 8, or 8, which means x equals what? Plus or minus square root of 8, and then I can simplify the square root of 8 to what? 2 and 2. So plus or minus 2 square roots of 2. Okay, so there are my zeros. I believe that's all it asks us to do. Find all the zeros and write answers in simplest form. That's why we have to simplify. So my zeros, x equals, I've got plus or minus 1/2 and plus or minus 2 square roots of 2. What questions do you have? It's the same factoring. It's the same zero finding. You're just going to have some square roots now. That's all it is. All right. So you do number 2. I'm going to give you a minute to get that one done. Are we all at least at this point here? So when I do this, I can take the square root of 4, but I can't take the square root of 3. Can I leave it like that? Nope, I got to rationalize. So my answer in the end is plus or minus 2 square roots of 3 over 3. So my zeros are plus or minus 2 square roots of 3 over 3 and 5. Okay. What questions do you have? All right, so that's pretty much it for the irrational numbers, because you already know what irrational numbers are. You know how to deal with square roots. It was just we're kind of adding them on to the factoring part so that we can move on to the fundamental theorem of algebra. Okay. So we're going to do something before we get there. We're going to talk about complex zeros. What do complex numbers make you think of? What? Difficult. No, that's not the right answer. Okay, square root over square root. So that is, and that could possibly be the case. But you started talking about complex numbers in Algebra 2 when you learned what? Do you remember? Imaginary, okay? So complex and imaginary don't mean the same thing, but chances are really good, I mean, I don't know this 100% for sure, but you probably didn't even talk about complex numbers, like using those words, until you started talking about imaginary numbers, because there really isn't a need to until you get there. And then that causes you to connect them, which is not a bad thing, just know that they're not exactly the same thing, and I'll explain that in just a little bit. But so your imaginary numbers includes I, right? What is I equal? Mathematically, like not what does it mean, but like what is it literally? Okay, when you take the square root of a negative number, but this in itself is equal to one specific thing. It's the square root of what? -1, right? Square root of -1. So if I have the square root of a -36, that's the same thing as the square root of 36 times the square root of -1. So that would give me 6i, right? Makes sense? So that's how you, well, I'm not going to split it up every time. We're just going to jump from here to here, but basically that's what's happening, just as a little reminder there. Okay. All right, so this says, just as a polynomial function can have real zeros, and that's all we've been talking about so far is the real zeros, and they could be rational or irrational, it can also have complex zeros, right? And then we're going to find all the zeros and simplify all irrational and complex solutions. So let's look at number 1 here. I've got, I'm going to factor this, and this a is 1, so I can jump to my little 2 parentheses here. I know that this is x squared and x squared. So I need 2 numbers that multiply to give me a -12, add to give me -4. -6, +2. We all agree with that? Can I factor that anymore right now? No, like that's it, because that's this one I wouldn't be able to anyway. This one, if this was a perfect square, but it's not. So I'm going to find my zeros here. It's going to give me x squared equals 6. So x equals what? What do I write down first? Plus or minus square root of 6. Not going to make my head explode. All right, I'm going to put you all on the naughty list. So then this one gives me x squared equals -2. So that means x equals plus or minus, and that's going to be the square root of -2, which will be plus or minus I times the square root of 2. Now you could write it as the square root of 2i, but it's a really good idea to put your square roots at the end. That way there's no question about what's underneath the square root sign. Okay, so that's why we kind of put that in front there. All right, so then my zeros as a whole are plus or minus the square root of 6 and plus or minus I square root of 2. Oops. What questions do you have? So still factoring, finding zeros the same way, we're just adding the imaginary numbers back in that we learned last year, okay? All right, so then y'all do number 2. So when I get to x equals plus or minus the square root of -8, what does the square root of -8 become? Well, just when I simplify the square root of 8, what does that give me? 2 square root of 2. And then that negative in there brings out an I, so I would have 2i square root of 2. What questions do you have? You can do that? Yes? Knock off the cobwebs and you're good to go? All right, let's talk about the fundamental theorem of algebra. So I'm going to give it to you, and then we'll talk about what this means. So it says a polynomial function of degree n, where n is greater than or equal to 1, has at least 1 0 in the complex number system. So a polynomial function degree n, where n is greater than or equal to 1, has at least 1 0 in the complex number system. Then it goes on to say, any real number is also a complex number. So this is why you can't think of, like, complex numbers should make you think of imaginary numbers, but they're not the same. Just because you have a complex number doesn't necessarily mean you have an imaginary number. So let's talk about just a parabola. Okay, I've got 3 options when I have a parabola. I could have no zeros and it looked like this. I could have one, or it could be down here, obviously, or I could have 1 0, or I could have 2 zeros. Now, there's a problem with the way I just said that, because that's usually how we say it. I'm probably guilty of it too. It doesn't mean, this actually doesn't mean no zeros. It means no real zeros. This means 1 real 0. This means 2 real zeros. Does that make sense? Because you still have, this is why you get imaginary, or this is why you get imaginary numbers here. So I know with the parabola, since it's an x squared, I can't have more than 2 zeros. And this says at least 1 0 in the complex number system. That means at least one of these 2 numbers, which I know are real numbers because I can plot them on that axis, are also complex numbers. So let's think about what complex numbers look like. A complex number is a plus or minus b times I. So let's say that I had 2 plus 3i. That's a complex number, right? A equals 2, b equals 3. Let's say that a then is going to equal 0. Then that would give me 0 plus 3i, which is just 3i. Or b could be 0, and I could have 2 plus 0i, which is just 2. So the real numbers that we think of as real numbers are complex numbers. It's just that b equals 0, and we don't write it that way. Okay? So I just want to make sure you understand what a complex number is, that all of your real numbers are complex numbers, and that's why this says what it says. Now, this theorem doesn't change anything that we are doing. It's just telling you that you have to have at least one. But giving you this theorem when you actually take algebra would really make no sense because you haven't even talked about complex numbers yet. And then next year you will learn the fundamental theorem of calculus and go from there. Okay? Let's look on the other side and let's see what we're doing here. We are doing linear factorization. And this linear factorization theorem is going to sound very similar to something else we've written, but it wasn't exactly this theorem. So it says if C is a complex 0, okay, it's really any real number, of a polynomial function, then x minus c is a linear factor of the polynomial. So it's saying whatever your 0 is, x minus that 0 is a linear factor, which is very, like I said, very similar to something we've written before, and that's what you know how to factor. And then we're going to see what we're adding into this. So this says this means that all polynomial functions can be completely factored. Completely factored. And we didn't completely factor those ones on the front. So we're going to completely factor them here. So number 2, we just factored this one on the front, so we should be able to factor this pretty easily here. A is 1, so I will be able to jump to my 2 parentheses, get x squared, and then 2 numbers that multiply to give me negative 12, combine to give me negative 4, negative 6, positive 2. Okay, so my instructions say find the zeros of the function, which we can do, and then find the complete factorization of the function. This is not completely factored. It's just factored as far as I can factor it right now. So let's find our zeros, just like we did on the front. We ended up with x squared equals 6. So x equals plus or minus the square root of 6, right? And then x squared equals negative 2. So x equals plus or minus I square root of 2. So my zeros. And I'm going to write all 4 of them out this one time so I can show you something. I got square root of 6, negative square root of 6, I square root of 2, negative I square root of 2, because you won't always have double ones like that. Then my complete factorization of the function looks like this. F of x equals, these are my zeros, so then x minus c is a 0, right? And then I've got square root of 6, so this would be x what? Plus or minus the square root of 6? Minus. Minus the square root of 6, that's that one. Then x minus a negative square root of 6, that's where the plus comes from, so don't get mixed up when you're putting this stuff back in. And then I get x minus I square root of 2, and then x plus I square root of 2. That is my complete factorization. Here are my zeros. Okay. What questions do you have? So that's actually completely factored all into linear factors. We just have some imaginary numbers in there now. We good? All right, we're going to do the next one together because something a little different happens here. So I need to factor this. There is no GCF. So I'm going to do 9 times 4. That gives me a negative 36. So 2 numbers that multiply to give me a negative 36, combine to give me a positive 35. 36 and negative 1. So this equals 9x to the 4th plus 36x squared minus x squared minus 4. Do my grouping. That'll give me 9x squared times x squared plus 4 minus 1 times x squared plus 4. 9x squared minus 1 times x squared plus 4. I can factor one more time. This gives me 3x plus 1 times 3x minus 1 times x squared plus 4. So now I'm going to find my zeros. And this gives me x equals negative 1/3. This gives me x equals 1/3. Gives me x squared equals negative 4. So x equals plus or minus the square root of negative 4, which is plus or minus 2i. Okay. So my zeros are x equals plus or minus 1/3 and plus or minus 2i. But I have to be careful when I go in to put this into the factorization, okay? Because I'm not going to do x plus 1/3, x minus 1/3. Doesn't work that way because look, I had my factors right here, right? If I know that x equals negative 1/3, I'm not going to put, there's not going to be any fractions that I put in there. So to solve for x, I'm going to multiply both sides by 3. 3x equals negative 1/3. And then, no, it doesn't because I just multiplied by 3. Good Lord. equals -1, then I can add the 1, and there's where your 3x plus 1 equals 0. Okay? So you don't have to actually go through this process, but that's why we're putting that in. We're not just going to add 1/3 to both sides. Because in the end, it's got to multiply back to match this over here. So my factorization looks like this. That negative, or that the positive 1/3 is going to give me 3x minus 1. The negative 1/3 will give me 3x plus 1. And then I have x minus 2i and x plus 2i. Then you can check yourself that if you multiply all the x's together, 3x times 3x is 9x squared times x is 9x to the 4th, and that's what we would have. We would not get that if we put the 1/3 in there, okay? What questions do you have? We good? All right, you do the last one. You're done. Check yourself with me, and then let me know if you have any questions.